It says linear programming, which is, if a lot of times whenever we use real world problems, it's called linear programming. I prefer, but it's the same idea as solving systems of linear inequalities. Usually we will use linear programming when wanting to maximize or minimize something. We'll talk about how to do that. Whenever you maximize or minimize something, you've got to find the vertices of what is called the feasible region, or the solution area is what some people refer to it, which probably makes more sense anyways. So you have to find the feasible region. Now, this isn't a great picture because it doesn't show the whole lines, but you would get this if you had these lines on there, and according to the shading of all four of those lines, you end up with that shaded region. Okay? So once you have this feasible region, you've got to identify the vertices. Okay, so Trent, tell me what the top left vertices is. Elisabetta, tell me what the top right is. Casey, the bottom right. And Tanner, the bottom left. Negative 3, 3. 1, 3. Casey? 6, negative 4. Negative 6, negative 4. Now, today we're mostly going to be maximizing or minimizing stuff, and we'll use those points to do that. Before we get into that, you need to know that even though we're going to be focusing on the vertices, any point that I would put inside that feasible region would be a solution to the system of inequalities. Okay, any of those points would work in that system. Okay, any points outside would not be a solution to that. Okay. So, coming down here, the problems that you're going to have what is called an objective function. This is used to maximize or minimize something. Once we have the objective function and the vertices, we can do that, which is what we'll do on the next problem. The objective function, you will know it's the objective function because it will start off with P equals. And all you will do is, and it'll have X and Y in there, all you'll do is you'll take each vertice, you'll plug it into the objective function, and max is the highest number you get, minimum is the lowest number you get. Okay, and you'll see that on the next problem, and hopefully that will kind of fill in the blanks here. So, let's go down there. Alright, so looking at this, I believe on your copies, this area didn't get shaded in very well. You might shade it in. Okay. And then once you do that, Don, will you tell me the top left? Kate Sutterth, the bottom left. Cole, the top right. And Jessica, the bottom right points. So, Don, what's yours?
1-8.
1-8.
4-8.
4-8. Who else? Kate? 1-1. 4-4. Awesome. So it gave us the objective function up in the equation. The P equals 3x plus 5y. Every point has an x and a y, and all you'll do is you'll just plug the x in for x, the y in for y. Tell me what it equals. Right? Now on this one, it's all laid out nice and neat for you. But even if it's not, which most of the time it won't be, I would write this out one time per vertices that you have, or per vertex that you have. And all you'll do is that first vertex I had was 1-8, so I'm going to plug that in. The next one I have is 4-8. And so on. A lot of you are going to be able to do this math in your head. It's not, most of these will not be very difficult. Alright, 3 times 1 is what? 5 times 8 is what? 40. 40 plus 3 is? 43. If you cannot, that is fine. Just do them separately. 3 times 4 is 12. 5 plus 8 is 40. 12 plus 40 is 52. Okay. 3 plus 5 is 8. 12 plus 20 is 32. Alright, so Sam, looking at those 4 numbers, which one is the largest number? 52. So there is the max. So whenever it asks for the maximum, the max is 52, and we got it from the point 48. Yasmin, what would the minimum be? From what point? From which one? Yeah, so what ordered pair did we get 8 from? Which one? 1, 1. Okay. Sorry, didn't hear you. Alright. So this, in my mind, this is kind of the easier part of today's stuff. We're going to turn around the back, and then we're going to actually have to graph the inequalities. So let's remember, if it is just y equals, is that a vertical or a horizontal line? Horizontal. Y equals is horizontal. X equals is vertical. Okay. Before we get into the graph, go ahead and label these. Don't do every one. Just do every other one. Make your life a little easy on yourself. I know, right? Okay, so like we said, y equals 6 is a horizontal line at 6. X equals 1 is a vertical line at 1. Those should be the easy ones that we can put on there. Now, if you like to do it by y equals mx plus b, even though it's not in that form, you can move stuff around, solve for y. You can get mx plus b. You can graph it that way if you want to. I'm going to show you a different way to do that. Okay, we're going to find the x-intercept, and we're going to find the y-intercept. Now, whenever you're doing that, what is always true about the x-intercept? It's whenever y equals 0. And for your y-intercept, it's x is always 0. Okay? So I'm going to use that to find the x value for my x-intercept and the y value for my y-intercept. So first finding the x-intercept of that first one. I'm going to take 0 and I'm going to plug it in for y. Now for solving this, I don't necessarily need the inequality. I'm just solving for x. So 5 times 0 is what? 0. So that cancels that. And I'm just left with 4x equals 40, so x equals 10. There's my x-intercept. Solving for the y-intercept. Same idea. But now I'm going to plug 0 in for x. Again, that cancels that. And 40 divided by 5 is 8. Now all I'm going to do is I'm just going to graph those 2 points. So I've got 10, 0, and I've got 0, 8. And I'm going to connect those 2 points. Now going to the next one, I'm going to show you an even shorter way to, it's the same process, but it's just a different way to look at it, and it just makes it a little bit easier. There we go. Alright, so looking at the second equation. Instead of plugging 0 in for y, you can already know that if I'm finding the x-intercept, all I have to do is take the term that has x in it and set it equal to whatever the equation's equal to. Because I know that if I put 0 in for y, that's just going to cancel that term out anyways. So for the x-intercept, I take the term that has x in it, and then whatever the equation's equal to, and I solve for x. So my x-intercept is 10 again. For my y-intercept, I just take the y term and what the equation's equal to. My y-intercept is 4. So take those 2 points and I will graph them. So I've got 10, 0 and 0, 4. So your graph should look similar to this. If you have started shading, please stop. I'm going to talk about the shading on these. Alright, so let's go through this. We're going to go through each equation. Again, do not shade right now as I'm shading it up here. I just want you watching this because I'm going to shade probably differently than the way you were taught. If I'm doing a system of inequalities, I shade differently. Okay, but let's do common sense, which is probably the way you were taught. The first equation, 10, 0 to 0, 8. That inequality is less than, so am I going to shade above or below that line? Do what? Below. Okay, again, do not shade right here. So let's say, okay, so I shade below that line. There it is. And let's say I'm even one of those really organized people that walk around with a 72 pack of highlighters every day, and I can have it all nice and color coded. So this one I've got 10, 0 and 0, 4, and that inequality is greater than, so which am I going to shade above or below that line? Above, because it's greater than. So I take that line and I'm going to shade all this. Okay, all nice and color coded and pretty. Okay, there it is. Then I've got y is less than 6, which is this line. So is that going to be above or below? Below, because it's less than, right? Get my awesome pink one out, and I'm going to shade below. Okay? And then the last one, and you always have to be careful on the ones that just have x. Okay, because this is x is greater than 1, which is a vertical line. So you can't think above and below. You have to think to the right and to the left of those. So if it's greater than, am I going to shade to the right or to the left? To the right. Okay, so I do this, shade everything to the right. Okay. Alright, so I've got my graph, I've got it shaded. Now I got to find that feasible region that we talked about on the front. Okay? Does everyone see why I do not want you to graph it like this? Because where in is the feasible region?
Right in the middle.
Yeah, okay. So what we're going to do, how we're going to actually shade this, is we're going to shade opposite the sign. And once we're done shading it, remember what that looked like and remember what you're going to have on your paper, and you'll probably be able to tell why I shade it this way. Because if you do it with a pencil, which is how I would do it, because I don't carry around, that many highlighters on me. If you do, that's fine. But with a pencil, with one color, you can imagine how much more confusing that would be, much less with the 4 colors I use. So let's go back. We're going to shade opposite the sign. So I've got my 10, 0, 0, 8 line. That is less than, so common sense would tell me to shade below, but I'm going to shade above it because I'm shading opposite the sign. Yes, so please be doing this now. So I'm going to shade above the 10, 0, 0, 8 line. It does not have to be all nice and neat, just, okay. have it enough to where you know that that part's shaded. Alright, the next one, I have my 10,0,04 line, which is this one. That sign is greater than, so now I'm going to shade on which side below. So I'm going to shade below this line right here. The next one is y is less than 6, less than or equal to 6. So am I going to shade above or below that line? Above. Now, if you already have a big chunk of that shaded, you don't have to shade over shading over shading, okay? Just shade the part that is not yet shaded above that line, which is just that little triangle right there. And then the last one is x is greater than or equal to 1. So am I going to shade to the right or to the left of that? To the left. Which that is just this little area right there. And now, your feasible region on the graph is the part that is not shaded. So, yes, because you'll have to find, because the next thing that we'll have to do is we will need to find the vertices. So you can hopefully see the importance of graphing it accurately. Okay, and that would be my feasible region right there. Okay, so I would go through, let's go ahead and just identify these. Anytime it's right there, I'm not going to give you a confusing decimal. If it's in between, just do 0.5. So that would be 3.5. And then I've got 10,0. I've got 1.6. And I've got 2.56. It's just these, the vertices or the corners of this one, of the feasible region. So I don't have an objective function on this one. We will have one on the next problem, but you would then put those points into the objective function, identify the maximum, the minimum, and tell what point you got the maximum and minimum from. Yes, some more stuff. Yeah. Okay. All right, so again, if it is x equals, it's vertical, y equals is horizontal. Go ahead and label your values on your x and y axis. And I've got a line that is x equals 5 and y equals 0. Alright, so looking at, to find the x and y intercept of these. Now, with how we found these, can somebody tell me why it is nice whenever I've got x plus y? Do what?
It's always going to be the number that's equal to.
It's always going to be, both the x and y intercept are both going to be 6. Okay? Because I would plug 0 in for y, which is just would make that y 0. So x equals 6. And then the same thing just with the plugging 0 in for x. So I've got 0, 6 and 6, 0 as my two intercepts. And I can connect those 2 points. So doing it that way, Emma, can you tell me what the x-intercept would be for that second equation? Wouldn't be. So whenever you do the x-intercept, you're just going to ignore this, ignore the y term. So you've got 2x equals 8, so x equals, what's 8 divided by 2? 4. So it's just like you're solving for x. So that one's going to be 4, 0. Trevor, what would the y-intercept be? The y-intercept. So I'm going to ignore the x term. Do I have to do anything to solve for y? No, there's no coefficient right there. So it's 8. So I've got 4, 0, 0, 8. So now I'm going to shade. I've got 6, 0, 0, 6. That inequality is less than. So am I going to shade above or below that? Above. Shading opposite the sign. Okay. The 4008 line is greater than. So am I going to shade above or below that line? Below, which is just the bottom left corner of that graph. X is less than 5. To the left or to the right of that line?
Right.
To the right, which is it's just this little bitty corner down here. That's the only thing that's left to shade in that area. Right. So now that I have that, I need to identify those 4 vertices right there. Kate Walker, what is one of those vertices? So I'm looking at this region right here.
Oh, you shaded the other one?
Yes, ma'am.
Okay.
Two what?
I think my graph's wrong.
2, 4. Okay, what's another one?
Say my name.
Yes, ma'am.
5, 1.
Okay. Brianna, what's another one?
5, 0.
And Sophie, what's the last one?
1, 4, 5.
4, 0. Yeah. Okay, so now I will take my objective function. P equals 3. I'm going to be multiplying that by the x values plus 5 times the y values. And since I have 4 vertices, I'm going to do that 4 times. We should have found that the maximum was 26 from the ordered pair 2, 4. The minimum is 12. From the ordered pair, 4, 0.